Alright. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. So basically, I will start the session, the workshop on ICAS. And so I will be managing the first part of the workshop, whereby later on in the second part, Dr. Lafiza will take over lah. Okay, so I have a slide here, but I won't play it in the slideshow mode because I would later navigate from one page to another. So I think I will just present like this. So basically, just some recap on what we have covered. I'm sure all section are on the same what you call same topic, I guess. So basically, if we look at this outline, so basically this is the outline of chapter 4, right? So so basically now we are at this stage, which is software for CAMD or CAMBD problem solution. Okay, so whereby the software which will be covering in our which we will cover in our class, which is ICAS. Because if you read the textbook, right, so it says that basically there are many different softwares out there that you can do that you can use actually for CAMD. But since one of the author is Professor Gani, right? So basically, ICAS is one of his so-called baby lah, which is ICAS software is one of his what you call it as a signature software lah. Okay, so this is the part where we are at now in chapter 4. So basically, and after that we will discuss a bit on the CAMD and CMD solution approach. I think we will cover also here in this workshop through the case studies which you will go through with Dr. Ala later on. And for chapter 4 we only have another week lah, which is on case studies. So next week we will be focusing more on how to apply what you have learned today, you will be learning today in several case studies. Okay, so basically in our workshop today, in terms of the software, so basically the software is ICAS. Eh? So of course, if you open ICAS, you can see that there are many different what you call many different tools that you can use actually in order to perform many tasks, right? But in our class today, we will cover just several of those tools which are related to our class, of course. Dr. Sawadi, maybe you can help me mute the entry tone because it's disturbing. Okay, so basically today we will be covering the first one is on CAPAC database, which I will cover, and then the second one is on ProPred, and then the third one is on the utility tool, which covers for phase equilibria such as SLE, VLE, and LLE. And then finally, Dr. Alafiza will cover ProCAMD, ProCam, which is the main, the main tool that we can use in order to solve CMD problem. Okay, right. So just some introduction about the software. So the version of the ICAS software that we have now is version 18. So 18 represent 18 years lah. So basically it has been developed for more than almost 20 years. Okay, so it is developed by the Computer Aided Process Product Engineering Center, CAPAC. So that is why you may find that one of the database is called CAPAC database, because so basically CAPAC stands for the center. So this center was in Technical University of Denmark, because now the center is no longer there in Technical University of Denmark, because Prof. Raffi has already what you call retired lah, and he already opened a company. Okay, so the software is called ICAS. So what is ICAS? So ICAS is actually integrated computer aided system. Because as you can see that there are many tools, right? It involves the integration of tools. that like the flower that you see here. So basically there are many different tools and functions that iCast can do lah. Okay, so and iCast is not a commercial software like Aspen Plus. Therefore, it is not. I can say that it is not quite stable. For example, when I want to open ProPrep, sometimes I will have some problems. So if you also have those kind of problems, it's normal lah. And I can also say that sometimes it is not very user friendly. So you need to. This is important to note so that you don't feel frustrated lah, because it is that's the way how it is lah. But of course, with iCast we can do a lot of things, and it will be very very useful for our class, because of course it can simplify the tasks needed lah, for CAMD. So basically, when you open iCast, I don't think I have to explain to you how to open iCast. I'm sure all of you know how to open iCast. Otherwise, let me know in the text box, comment box, text box lah, in the comment box if you have any chat box. So when you click iCast, then you will see this interface. So this is what we call as the main interface, right? So this is the main interface of iCast. And then here you will see there's a task manager here. You can't open the software. Have you opened it before, Money? Have you tried to open it before? Basically, you can just search for the yeah.
Dr. Aziza, I will help on the chatting.
Okay, all right. So basically, if you have opened it before, then you should be able to open it again lah. It's only that sometimes, like I said before, it may be unstable, it may be have problem. Maybe what you can do is that maybe you can try to restart your computer lah, try to restart it, and yeah, maybe you will get lucky and it can open. Sometimes that's how I did it lah. Maybe you can try to restart it, and hopefully it can open lah. Okay. It's okay, Mani. Later on, we try to sort it out. Okay, so we have this task manager. So basically, user may decide to use the tools in a standalone mode or in an integrated mode. So the tools listed under task manager here may be used on a standalone mode. So basically, there are many tools here. So basically, you can use this tool as a standalone lah. So it can stand alone. You can just use that particular tool, or you can also integrate it with other parts of the software. Okay, and the tool list in this, if you look at the top part of the here, at the top part of at the main interface, you will see that in the second line, you will see you can also see some icons or buttons that you can press, which are actually also with respect to the same list of tools that we have here lah. Okay, so basically you can either click any tools that you need to use here in the taskbar, or you can also click anywhere up here lah. Okay, so this is just some description of some of the tools that we will cover today. So the first one is on CAPAC database. So now you know what's the meaning of CAPAC, right? So it's the name of the center. So CAPAC database contains a static database of pure component properties and mixture properties, and also model parameters. Later I will show you the database. So this one is just for introduction. And then the second tool that we will look at is ProPrep. Okay, so using ProPrep, we can do pure component property estimation and analysis. Okay, and then I will also show you the utility tool whereby we can perform phase equilibrium calculation involving VLE, SLE, LLE, VLE, SLE, and LLE. And then of course, it is with respect to functional. We can also calculate the functional pure component properties. And then finally, we will cover ProCam, whereby you can do design and selection of components such as solvent with desired properties through computer-aided molecular design. So basically, the steps that we have learned in chapter 4, we will see how we can implement it in using a software. Okay, because it's quite impossible lah to do design manually. So we need to use we need the use or the help of computer tools lah. Okay, so in terms of the manuals, you can also read the manuals of many different tools that we have in iCast. So basically, you can go to your C drive, go to folder CapPack, iCast, docs, and manuals. Then you will see a list of the manuals. Okay, so this is the. Can you see my folder? Or are you still seeing my slide?
Alright, nampak.
Okay, so this is the folder lah. CapPack, iCast, doc, manual. So these are the manuals of many different tools. We have manual for ProCount, for ProPred, and many others. Of course, we don't use everything lah. Okay, so going back to the slide. Okay, and then so in terms of CapPack database, so what can we do with the database? So we can investigate the database for compound information. Later on, I will show you how. We can also add a compound using ProPred. If let's say there's a certain compound which we are interested in and it is not in the database, so we can add it in the database. For example, using ProPred. And then we can also edit compounds that we have created in the database. Let's say we have obtained new information, maybe new data on for that particular compound that we want to add in the database. We can do that. And then we can also create a compound by cloning existing compound. Okay, and later on you can read the slide because I already we already distributed this note, right? So maybe later on you can just read the notes and see how you can do all this lah. Today I think I will only discuss about how to search the info and how to read the data that we have lah. In terms of adding new compound in terms of adding new compound, cloning existing compound, I think you can try to do it on your own later lah. Okay, so I think maybe we can go to the database. Okay, basically we just open the iCast database. The iCast software. So then we will see this interface. Can you see the iCast main interface now in your screen?
Yes.
Okay, all right. So basically, in order to launch the database, we just go to this. We click this button, this M, the red M button here. So it's called Database Manager. Okay, so I hope you can do this together with me. Okay, maybe if you have two devices, then it would be better lah. One with your iCast, another one with the WebEx. Okay, so what we need to do now, in order to launch it, you just click the button lah. We click it, then we will see this window. Okay, this is the window. Okay, we can maximize it. Okay, so basically, I just want to show you how we can look for data of any compounds lah. So what we can do is that we go to the left side of this window, we click basic search. Click basic search. Then we will see this view. Okay, so there are three ways how we can search the compound, either through its name, formula, and also CAS number. Okay, so let's say we want to search for cumin. So we can type here, type the search string. We can write it. We can write the name, because here we activate the name button, right? So we write the name. After we have written the name, then we click this button, search CapPack database. If you enter, nothing will happen. So that is why it's not that user friendly. Normally when we write it, we just want to enter, right? So nothing happen. So we need to click this button, then only it will show you the search result. Okay, so we click this one. So you can see that there are two compounds here. So of course we are interested in cumin, so we just click the name here. Just click it. If you double click it, nothing will happen. So when you go to this part, you click at the name, and then you need to click view compound. Then only you will see the details. Okay, then you click view compound. Okay, then you will see the properties page. Okay, so we have many pages here. So if you refer to properties page 1, we can see the name and its other names. For example, 1-methyl ethyl benzene. So that's another name for cumin, right? And then we have there's a CAS number here, formula, smiles is another way of how we can represent molecular structure. I'm fast. Do you want me to go back? Somebody said that I'm fast. Okay, maybe I can close this one.
Yes, go back, please.
Okay, open iCast. Have you opened iCast? Where to open the software? Can you see me how I yeah, because if you know how to use computer, you should be able to open an software. And because we are not trying to teach basic computer how to open, you should be able to open the app. That one you need to sort it out lah. Okay, so after you open iCast, you will see this main interface. And in fact, this workshop is recorded. If you think that I'm too fast, you can just see the. I will show you. Can you see me doing this? Clicking the start button. Can you see this view? Whereby there's a list of software that I recently used. Can you see this? Yes. Okay. Good. So then what I also don't have a shortcut on my desktop. So what I did was I go to the search. I just search for it. And you just search it here. So I just write it here, iCast 18. Then it will appear here. So you just double click that icon. So that's how I open iCast. Okay, I also don't have it. I don't have the shortcut on my desktop as well. Okay, so just search for it and then just open it. Okay. So if you are using your computer, if you have any problem, just go to the search part. You search whatever you want to search. Okay, it's because you are an engineer, so you need to be able to do troubleshooting. Even though you are a chemical engineer, a good chemical engineer must be good at computer, not only doing experiments. You must also be good at using computer. Okay, so things like basic like that you need to be able to know lah. Okay, all right. So okay, going back to the database. So basically, what you need to do, you need to click this button. Okay, and then open it. Okay. If you can't follow, you just watch the video lah, and just watch the Webex, and then later on you rewatch the recorded video. Otherwise, because I can't really be very slow. Otherwise, I can't cover everything. Because my part is only just a small part of the whole workshop. Because Dr. Alafiza will cover most of the workshop which is on Procam. So I need to go quite smooth lah, not very slow. Okay. All right. So this is the database. So maybe we can maximize it. So I just want to show how you can search for compound and see the properties or the details with respect to that compound. So we can just click here, basic search. Okay. Then when you click it, then you will see this view. Okay. So there are three ways how you can locate or search for a compound: through its name, formula, or class number. Okay. So if we search through its name, then of course we need to write the name lah. Okay. For example, here is cumin. After you have written cumin, then you click the search CapacDB button. To click it. When you click it, then you will see some list. Okay. So of course here we are interested in cumin, so we just click on cumin just to activate it, and we click view compound. Okay. I also have provided you a handout, so you can just refer to the handout. Okay. There's also some detailed steps there. Okay. So when you click that one, view compound, then you will see this properties page. Okay, here properties 1, we can see the names, the cast numbers, some details on the smiles. What else? And then here we have endpoint ABC, endpoint parameters, ABC and the range. And then in properties page 2, you will see some other properties. We have primary properties, secondary properties here, all these details. And then in property page 3, we will see some correlation with respect to several different functional properties and its parameters. Okay, and the mean temperature and maximum temperature and its equation, the detailed equation. Okay, and then we also have here solvent properties page, whereby we can see some solvents, whereby cumin either miscible or insoluble in. For example, insoluble water. So basically, cumin is insoluble in water. In ethanol, so cumin is miscible in ethanol. So those are the information. Okay, and then there's also the last one is the group description. Okay, you click the group description tab, and then for the model, maybe we can choose unified, and then we will see the vector the group vector for cumin. Okay, so in cumin there are 2 CH3 5 ACH, but there is some error here because there are many ACH. There should be just one, so there is some error there lah. Yeah. Okay, right. So basically these are the information that you can get from CAPAC database, and you can also see the molecular structure. You can click view molecular structure. See, so this is the structure of cumin. Okay, so it's just like that in order to search properties. It's only that it's not that user friendly lah. For example, if you search for benzene, search, so there are many lists. So it's not really specifically going to that particular compound that we want, because of course, in all these chemical names, we have benzenes. So maybe other way that you can do, maybe you can try to use formula, for example. Loges, okay, Loges and everybody, like I had informed before lah, ICAS is not that stable. Sometimes we have problems, so we need to bear with that lah. We need to bear with that. So if you have problem, nothing I can do. Just you can try to just close it and reopen it, restart your computer. That's how I normally do it. Okay, so if you have that problem, nothing we can do lah for now. It's just that's the way how it is. ICAS. It's not a commercial sort of software. It's just for learning and for something. Okay, so sorry Dr. Alan sebab dah ternampak kan. Nak terjawab pula. Okay. Alright, so benzene. So how to search? If you search by name, then there's a lot of benzene. Of course, you can try to scroll and find which benzene that you like. But yeah, so we can try to use other ways lah. Formula, for example, then of course formula for benzene is C6H6, right? Benzene, and then if we search it, then of course still there are many. Okay, so what we can do? So maybe we can we can search for the CAS number, because the third way that we can use is by using the CAS number, and the CAS number will be specific for that particular compound. So we can opt for CAS number. So, but before that, we of course we need to find the number, the CAS number in the internet. Okay, so we can write benzene CAS. Okay, and then yeah, so there's we can see the number here 71432. Okay, copy that one and then go to the database. Another thing you cannot copy, you cannot copy and paste, so you need to memorize. 71432. Okay, 71-43-2, and then click search. There you go. So only one, because the CAS number is specific for that particular compound. Then of course you can view the compound, right? And then of course the same information you can also get. Okay, thank you, Usam, for the advice. Okay, properties page 1, properties page 2, right? All this data, and then the correlations for the functional properties, solvent properties page, and then the group description. Go to more unified. Still, I'm not sure why there's error here lah, but because the same group is repeating kan, but actually the description for benzene is of course 6 group of SCH. Okay, right. So basically for the database, I just want to show you that one in terms of how to search for the compound and how to look at the data with respect to that particular compound. Okay, so of course, like I've mentioned in the slide, you can also add new compound here. You can also clone existing compound, which I will not do because I don't think is important. But if later on you need to do that, just let me know lah. Or you can just look at the slide or the manual. Okay, so basically the thing that I'm highlighting is that ICAS is not yet that stable and user friendly, so you need to do some you need to adapt lah, to the disadvantages, and hopefully you will be able to get the needed data or compound lah, Okay, any question on the CAPAC database? Question in terms of the usage, not in terms of cannot open ICAS or cannot do cannot find the icon or whatever. Any question? No. It's quite straightforward, right? It's only that, of course, in terms of database, there are many different database actually that you can find in this software. If you go to this part, what you call this? Okay, you click this tab. I think you click this tab, database, and then you can change the database, change base. So actually, there are many available databases in ICAS, and one of it is CAPAC. How to know this is CAPAC? Just look at the end of the file name. You can see CAPAC here, .mdb. So CAPAC.mdb. So this is CAPAC database. You can also go to other database, for example, DIPPR database. You can click OK. Okay, you can also search for whatever compound that you need in the DIPPR database. So there are many different databases which are available in ICAS. Okay, and how to know that this what database it is now? You can just refer to this part at the bottom. So you can see here DIPPR MDB. So we are in the DIPPR database. Okay, so that is on the database. If there's no question, on to the next tool. So the next tool that I want to share, to discuss with you, or to show, to demo, is the ProPrep tool.
Dr. Azizo, sorry.
Yes. Yep.
One question.
Yeah.
So which database would you recommend to be used as the default database from so many databases?
Okay. So in terms of database, maybe I would suggest either CAPAC or DIPPR lah. But it depends, because sometimes certain compounds we don't have it in those two database. So maybe you can try to look for it in other database.
Okay, meaning these two will be the most recommended. So if we can't get what we want, then only we go for other databases, right?
Yes.
Okay.
But the thing with CAPAC and the IPPR database, we cannot edit. We cannot edit the database. So if you want to edit a database, then you need to create your own lah. For example, you can create new database, and then of course it will copy, for example, the CAPAC database, and then you can add whatever other data that you want to add. Okay, so because later on when you look at the manual, you will see that in order for you to, like for example here, okay, if you need to add new compound, okay, if you need to add new compound, then you need to change the database to user.mdb. Okay, user.mdb. If you need to change if you need to add new compound, because you cannot edit CAPAC and the IPPR database, but you can edit user database, for example. Okay, right. So moving on to the next tool. The second tool is ProPred. Okay, so what is ProPred? What is ProPred actually? ProPred is property prediction lah, short form for property prediction. So basically, it is a tool that can be used to estimate properties of molecules. Okay, so in order to estimate properties of molecules, what we need to do in ProPred, we can either draw the molecular structure, yeah, using the drawing tool, or we can import the SMILES description of the molecular structure. But I will only show you the second method lah, because it's easy. It's easier lah, especially if we know what compound that we are trying to draw lah. But of course, if we do not know the compounds, or we cannot find the SMILES of the compound, then we need to draw it lah. But I will not cover draw lah. In terms of how to draw, you can try to explore it on your own. Because draw is quite easy, right? You can just draw it. Okay. And then so the working area in ProPred, later on when we open ProPred, we will see that there are two parts of the page, or what we call as the working area. So the left part is what we call as the properties area, and at the right side is the drawing area. Okay, so these are the information. I mean, I think maybe we try to open it first. There are several ways, right, that you can open it. You can go to the taskbar and then click this button, and then you can also go to the top part of the ICAS. You can also click here, this one, or you can also click toolbox, the tab toolbox. You can also click property prediction. There are three ways how you can do it. But I myself have some problems opening ProPred. I don't know why. Sometimes okay, sometimes having problem. Okay, so that's why I already open it here, so that when during the workshop when I open, it can open. I can already use it. Okay, this one I already open. I don't want to close it and reopen because I afraid that maybe will have problem opening it later. Okay, but actually there are three ways how you can do it lah. Click by using the taskbar. You can click this button. You can either click this button or you can go to the toolbox tab and then click property prediction. Okay, if one of the if you click here something there's a problem, you can try the second one. Otherwise, you can try to click the third one. If something wrong, then of course you close ICAS, reopen ICAS. If there's still some problem, restart your computer. Okay, so yeah. Okay, so this is ProPred, right? So the left side is the properties area, properties page, and the right side is the drawing part lah. Okay, so all right, so this is the interface for ProPred. Okay, so for any structure present in the drawing area at the right side, so the corresponding property values will be shown in the properties area at the left side. And there are four property models that we have in ProPred, which can be used to predict primary properties. So we have Marrero and Gani, the one that we learned in class. Then we have Constantinu Gani. So basically Constantinu Gani, the difference with Marrero Gani is only that they have only two orders lah. Marrero Gani have three orders. Then we have Joubert and Reed, and then the last one is Wilson. And then later on, you will see that the properties calculated or estimated will be ordered in terms of the primary properties, secondary properties, and the functional properties. So later on, I will show you how we can import the SMILES description of the molecule that we want to draw, and then how we can import the SMILE and see how we can get the properties. So what is SMILE? SMILE is one way of how we can represent molecular structure. So SMILES is a short form of the simplified molecular input line entry system. So basically today we will not be learning on how to write SMILES for molecules. We will only use available SMILES and how to import that SMILES to draw the molecule and to estimate the properties. Okay, so this one I will show you a demo. Okay, so maybe I have some examples here. So maybe salicylic acid. So let's see how we can draw the structure for salicylic acid and estimate the properties using ProPrep. Okay, so we can go to the internet. So I can write here salicylic acid SMILES. Okay, and then we click, and then we can use this one from PubChem. Click this one. And then go to the right part at the table of contents under names and identifiers. Okay, and then we will see at this part canonical SMILES. You can click that one, and then go to the left side. So under canonical SMILES, we can see this coding ni kan. So these are what we call as SMILES. Okay, so it's like we have eyes and then we have the smile. Okay, just copy this. Copy, and then we go to ProPrep. Okay, and then I go to the right side of the window. I right click. So you right click, and then you will see this box. Go to import, and then you go to SMILES. Click SMILE. Then you will see this box. Okay, so what we need to do here, we just paste the SMILE that we have copied from the website. Okay, so here it is. So we just click OK. So it will ProPrep will draw the structure for us. Okay, from the SMILES that we have imported. So we don't have to draw it on our own. Okay, but of course, if you do not know the SMILES of a certain compound that we would like to know the properties, then of course you need to draw it manually lah. Because it's a bit tricky to draw. It's not, but you can try later on. How if let's say you need to draw lah. Okay, so when we import the SMILES, so the structure of the molecule is automatically drawn here, and then automatically also the properties will be estimated using the 4 methods that we have in ProPrep lah. Okay, so maybe you can click summary for the overall summary. So what we can get here is in terms of the primary properties here. So these are the methods. Okay, these are the methods highlighted in this table. Some, most of them are using Murray-Rogani. Some one of it is Wilson. We have Joubert Reed here, and these are the estimated values, and these are the units. So this is the primary properties. So this is the secondary properties. Okay, some properties are able to be estimated, some cannot be predicted, maybe because of missing parameters or data. Okay, so in order to know, because we can look specifically on each of the model. Let's say we click Murray-Rogani. So we click here on the tab here, Murray-Rogani. So we can look at the properties predicted using Murray-Rogani. So this is primary properties. And then we have what else? Ada banyak lah. There are many. At the end of if you scroll it at the end, you will see the list of groups which are assigned for salicylic acid. Maybe here we have first order group. We have ACH 4 times, ACOH1, ACOOH1. And then in terms of second order group, so we have one group here, our ROM ring. And then third order, no third order. Okay. So basically using ProPred, you can also look at, get information in terms of the first, second, and third order groups used in order to predict the compound. Okay. And of course, also try the others. We have some other example, for example, ibuprofen. So you can just go to the internet, write ibuprofen smiles. Okay, and then click this one, PubChem. Okay, and then name and identifiers, canonical smiles, and then copy the smiles here. It's impossible to memorize, right? So we need to copy and paste. Copy, and then here we right click, import, smiles, paste. Okay, so this is the structure and this is the estimated properties. Okay, so if we click Marero Gani, we can look at the properties. Okay, estimated properties here, primary properties, then we have secondary properties here. So these are functional properties, but of course, because of missing, I think maybe missing, I'm not sure, maybe because of missing parameter or something, then it cannot be estimated. Okay, and here are the group assignment, group vectors, first order group, and then second order, and no third order. Okay, and then of course you can try it for many different compounds. Okay, any question on ProPred?
No, doctor.
Okay, right. So moving on to the next tool. So next is I want to show you this SLE, organic SLE. What is SLE? It stands for solid liquid equilibrium. So it's important for extraction process, leaching process. So the use of SLE toolbox to calculate solid solubilities as well as binary SLE phase diagrams. Okay. So the steps, the details of the steps, you can refer to these slides. But of course, I will demo it to you. I will show a demo. Okay. So we go to the main interface. So this is to how to calculate SLE or to generate solubility curve. Okay. So first of all, what we need to do is that we need to draw a stream. So we click here, this part, this arrow. So this is to draw stream. So we draw a stream here. Okay, and then we need to specify the compounds that we have in this stream. So I need to click this arrow. So I just double click on the arrow. Something is running, so I need to maybe delete. Maybe ProPred. Okay. Okay, right. So when I click the stream, so we will see this page. Oh, sorry, but before that, I need to specify the compound. So in order to do that, I need to go to this. I need to click this button, specify the components in the system. Click that one. Okay, so there are many databases here that we can use. So maybe you can choose CAPAC database, for example. And then let me check the example in the slide. So the one which is used in the slide is benzene and phenol. Okay, so I will look for benzene and phenol. Okay, search here, benzene. Okay, like I've shown before lah, it's not that straightforward. Can need to find. Cannot find it. Maybe I use the deeper. Benzene. Okay, here is benzene. Click benzene and then you click add. Okay, at the right side. And then what was the other one? Phenol, Phenol. Right, phenol. Okay, we have phenol here. So we add. Okay, then we click OK. Then after that we click the stream. Okay, so we can already see the components that we have selected before. Okay, and then in this example, so maybe just for as an initial value, we can just put temperature here 300, for example, just an example. Okay, ATM pressure 1 ATM, and in terms of the molar flow rate, we just put 1 and then just put 1 there. Okay, so that is just to specify the condition, and then we click this one in order to specify the thermodynamic properties. Click this one. Okay, we'll see this box. Okay, and then we click this one. Okay, this is to specify the thermodynamic model. Okay, basically in this way we can see that we can perform many different calculations lah. Okay, but before doing that, we need to specify the thermo model first by clicking this portion. Okay, so click this one, and then this is the thermodynamic model. Okay, and then we can choose gamma phi here. Click gamma phi. Okay, and then we can select the models for the liquid phase, for the vapor phase, or whatever. So we just specify. Laju sangat ke? Okay, saya petak balik. Okay, I repeat. Okay. Okay, it would be helpful if you let me know which part that you are not clear, rather than just say I'm fast or I'm lost, because I can't help you if you say that. I can only repeat.
Doctor, can you please repeat the part where after we add the compounds, what we should do?
Okay, do you have the handout with you? The handout. Do you have it with you or not? Because when you refer to the demo, you should refer to your handout. Please refer to your handout. Okay, so let me repeat. Okay, so what do we want to do? We want to perform SLE calculation, whereby we need to calculate the solid solubility as well as binary SLE phase diagram. Okay, so basically, which is useful for leaching process, for example. Okay, so we go to ICAS. Okay, so we want to, first of all, what we want to do is that we want to draw a stream. Click the stream here and then draw the stream. Got it? Okay, so now this stream is only a stream. There's no information. So we need to define the problem. We need to specify the problem. Okay, by first listing the components involved. The system lah, right? So in order to fill in information in this stream, we click this button. Okay, in order to specify the components. So we click this one, then we will see this box. So the title of this box is Compound Selector. Okay, and before this, I've shown you some databases that we have, right? So you can see the list of the database here under available table here. So there are many databases. But I choose the IPPR. Okay, so based on the example that we have in the slide, so the system is with respect to benzene and phenol. Okay, so we just search for it lah. Based on the step that I've mentioned before. It's only that for each compound that you have found, you need to click add. The add button at the right side of this window so that it will add it in this part, which is the selected compounds. Okay, so these are the selected compound, benzene, phenol. Okay, then you click OK. Then in this stream, we already have the components, right? And then we double click the stream in order to further specify the system. Okay, first of all, what we do, we specify the temperature, the pressure, and also the molar flow rates. You just put 1 here. Just put 1 ATM, 300. Yeah. Okay. Because later on we will generate a T versus X, temperature versus composition diagram. So this temperature is just an initial value. Okay. Pressure 1 ATM. Okay, so we have specified, in terms of the condition of the initial condition of the stream. And then next, we click this one, this icon. Okay, this is to perform calculation, whatever calculation that we want to perform on the system that we have defined. Click this one. Then you will see this box. So in this box, we can perform many different calculations. There are many different calculations that we can do. But before performing any calculation, I would like to specify the thermodynamic properties, the thermodynamic models that can be used, which are suitable. So in order to do that, I click this button, which is thermodynamic model specification. Click that one. Then you will see another box. So this box is where you can select different thermodynamic properties which are available. Okay, but for this case, I under the phase equilibrium model part, I click gamma phi. Okay, so this one you already learned in thermo KK. You should know what is gamma phi. Okay, click gamma phi, then we can see that we can select liquid phase model. Liquid phase model. We can select vapor phase model. Select saturated vapor pressure correlation. But since we want to perform calculation for solid liquid extraction, so vapor may not be relevant, right? So we just click this one, select unified phase model. Currently, the assumption is ideal solution. That's the current assumption, ideal solution. But here we have benzene phenol. Okay, maybe it's not suitable to use ideal solution. Then what I do is I change the model. I don't want ideal solution. I want, for example, okay, maybe I can choose original unified, VLE, one parameter. Okay, so for unified model, I already discussed with my section, unified model. So maybe they know lah. So unified model is a type of model which is based on group contribution lah. Okay, so that's why we can see the parameters with respect to the groups, functional groups. Okay, so I choose this model as my liquid phase model. So I click OK. You can see here. So this one has been selected lah. Okay, and then I click OK. And then next, what I would do is that I click this one, default. So basically, for other properties, they will be using the default model. You just click this one. So when we click this one, we can see that for the heat of vaporization, it's using this model. For density volume, it's using this model. So those are the default models. And only the GE model, the liquid phase model are the one which we choose. The other one is default. Okay, after clicking default, then we click OK. Okay, after we click OK, then the window for the thermo model selection will be closed. So it will bring back us to the box whereby we can perform many different calculations here. So we want to perform the SLE calculation, so we can click organic SLE here, this button. Of course, there are many properties that we can calculate, right? Of course, there are many. We would just want to click this one. This is the utility toolbox lah, for SLE. So then we click organic SLE. So we click organic SLE, then we will see this box, this window lah. Okay, we can see the system and we know the melting points. Okay, so next what we want to do is that we want to generate the SLE curve, the solubility curve. So we click define. Okay, so there are two ways how we can perform the calculation. We can perform the calculation for the entire diagram. So it means from 0 mole fraction to 1 mole fraction. Or we can also do single point. Maybe we just want to know the solubility at a certain temperature. At a certain temperature, we want to know what's the solubility of the X. Okay, so here I want to show you how we can generate the overall, the entire diagram. So we click entire diagram, and then we click OK. Then here we can specify the increment. For the points that we want to generate for the whole curve, what should be the what you call the increment of the X axis. The lower the increment, of course, the smoother panggil. The smoother lebih the more smooth lah the curve. So we can just stick with the default 0.02, then we click OK. And then in terms of the mole fraction, this is the range. So we want to generate the curve from 0 to 1, or is it from 0 to 0.5, or is it from 0.5 to 1? So we can specify here, but I want to generate for the whole diagram. So I click. So the first range I write it here. I stick with the default 0. Okay, and for the end range is 1. So I click OK. Right, then we can. So here calculation complete, finish. Okay. So this is the diagram. So this is the SLE curve. Okay, and of course we can get information lah, because this is temperature, this is solubility. So we can know for certain temperature what is the solubility of the system. Okay, so this is the diagram. So in order to get the raw data, if let's say you need to see the details in terms of the values, or maybe you want to like do some modification or whatever, you can go to this address. We call it address or what? Let me show you. This one. Sorry, this one. Drive C, just work. So you can go to this. I can show you the the path. Okay. ICAS work. C capital ICAS work. So the output file for SLE is ICAS1 SLE. This one. So you right click this file. Yeah, and then open with. So open with a notepad. Notepad type of app lah. So notepad. And then okay. And then you will see these are the data. So this is the data. The temperature X1, X2. Okay. So S1, S2, it depends on how you specify the component too. Okay. So SLE is important lah for you to what you call see or measure the performance of maybe when you do a solvent design, for example, then you have many different candidates of solvents that you can perform SLE to identify solubility and compare between candidates and can select the best one. Okay, so that is on SLE. Any question on SLE? No question. Okay, so that is on SLE. Another one is on LLE, but this one you can try to do it on your own. Just follow the steps that I've shared here. Basically, it's more or less the same in terms of specifying components, the thermo model. It's only that for the thermo model, for the liquid phase model, we choose Unifact LLE. This one is specifically for liquid extraction lah. Okay, and then when you want to perform the calculation, you click organic LLE. Okay, and then you will see all these boxes, and whereby when you see this window, you click calculate and plot, and then you click OK. There are several curves that we can draw at different temperatures, so we can specify the temperatures that we are interested in, and then we click OK. Then at the end, we will get this ternary diagram. Okay, this one you can try to do it on your own. So liquid is also important for, of course, extraction process and liquid extraction process, whereby you can identify the best solvent that we can use to extract one compound from another kan. Okay, so it's already 12, 7 minutes. I don't want to take Dr. Alafiza's time too much. It's already exceeding my planned time. But if you have any final question? No? Okay. So if there's no question, I think that is all from me. Dr. Asmadi, maybe we can continue the next part.
Okay. Thank you, Dr. Azizul. Okay. Any questions from the floor? So okay, if no questions, it's already for the Dr. sessions, and I think he have another things to do after this.
Assalamualaikum and good afternoon. So, can you hear me?
Yes.
All right, good.
Yeah.
Okay. Hope that because I'm online from UTM. Sometimes the internet connection here is not really good, but if you have a problem to hear me, just notify me, okay? All right. Dr. Azizul give you overview on the ICAS. Now I will continue on the CAMD. So this is on the ICAS. All right. I won't explain on this, but I just want to show you where you can get the CAMD tools. Here is actually on the task manager here. You can see there are lots of the tools available, but in our case, it's actually we use the CAMD ProPred that has been demo by Dr. Azizul. And then we also have a Solvent Pro, is for the solvent selection, but this one, I won't cover this one. Okay, I think the most important is two tools here, Pro CAMD and then ProPred. So this ProPred here, you can either click this here, this button here, or you can see the button under toolbar. Next to the ProPred, the green color, there is CAMD, Computer Aided Molecular Design. So either one, you can click this one or this one. But normally I did this ProCam. So can you see my, once you open the ProCam, it's actually ICAS is actually not connected to ProCam. So you can actually just close the ICAS and then open the ProCam. So this is the interface of the ProCam. Since has been mentioned by Dr. Azizul, this ICAS software is actually free for education, so it is quite unstable. So during ProChem, you need to do some precaution when we do the design using ProChem, which is we need to save all our works. All right. This is the main interface, but the left hand side is just empty. What you need to do is actually you need to define what type of the molecules that you want to design in the left hand side here. Basically, there are general problem control, this page. And then you click the non-temperature dependent properties. You can see appropriate properties, minimum, maximum, so forth. And then temperature dependent, azeotrope or miscibility calculation, biodegradable calculation, mixture properties. All right, so this tab you can just click. All right, so go back to the general problem control. Problem title, you can name according to your problem. So you refer to the PDF document that I share with you. I label as case study 1. I have 3 case studies. Case study 1, we start with the simplest one first. And then next, page 3, I have case study 2, phenol removal. And then case study 3, this one is the most complex problem. So, all right. We start with the first one. The title here in the general problem control, you can write any title as you like. So you can, for example, you want to design, you can write anything, design molecule, for example. All right, so in this case study 1, I name it design of molecule using ProChem tool. And then I don't open the document. I just hope that you have next to you because I don't want to disturb on this interface. I have a hard copy with me, so I can refer to the hard copy. Design molecule, and then the design all feasible molecules that satisfy the target constraint given below. So in the case study I gave you, the molecules must have a set of descriptors, or sometimes we call groups. It must have CH3, CH2, OH, CHO. All right, you have the generate here. You have a cyclic, aromatic, cyclic, and then generate isomer. So normally you can select either one here. Case either a cyclic, which is a long chain molecule, aromatic, which is it has a benzene ring, or cyclic compounds. It give you a different design. You cannot combine together. Just one case, each design. Since this case study give you to design that has CH3, CH2, this one in a cyclic compounds. When I click a cyclic compound, you can see the selected group at the bottom here will change. Let's say I tried aromatic, so you can see the selected group change here. Cyclic compound, the selected group change. So every time you select the different, it will change groups. All right, so since we need to have CH3, CH2, so when you click a cyclic compound, so these are selected groups. Actually, when you select a cyclic, it will choose the common groups for the alkane, hydrocarbon alkane, C and then H. So that's for the cyclic. Same for the cyclic. So common for the C and H. All right. So when we want to have a functional group, you need to select at the bottom. Oh, by the way, you need to generate isomer. Every time you do the generation, tick the generate isomers. And then move to the next box. You need to select this one we call as functional group. So in the description given, it must have alcohol. So you tick the alcohol. And then CHO is for the aldehyde. So tick aldehyde. So you see at the selected group, is now appear OH and CHO. All right, so this one, and then this one is actually under the general problem control. Design a cyclic compound, select alcohol, aldehyde, and then tick generate isomer. So basically you have done that, right? And then under guidelines, you have the second point, the size should be from 2 to 6 groups. So this is the size should be from 2 to 6 groups with maximum 1 functional group. And then select the perform database search after generation. So we go to the, scroll down to the bottom. Backbone, you don't have to do this one for the polymer. And then if you want to edit groups, you can click edit groups, and then you can add on or remove. You want to define specified compounds, you can do here, but since this one is the base case, we just leave it there. No need to do. And then here, add standard problem control. Here is actually normally when you did the manual design, is mentioned by the restriction given by Dr. Azizo, how many groups, and then here is actually you define. It's asked minimum number of group is 2. This one, the values here is by default. By default, 280606 default. So you need to change. The first one is the size should be from 2 to 6. The minimum 2. The maximum number of group is 6. So click the down arrow button or up arrow button to increase or decrease. So 2, 6. And then minimum number of functional group. It doesn't mention minimum. So leave it as 0. The maximum number of functional group is mentioned in the maximum 1 functional group. So you need to have 1. So reduce to 1. Yeah. And then minimum number of same functional group is didn't mention. The maximum number of same functional group. Okay, since we have the 1 here, so here you also decide as 1. The same functional group. You cannot, since here it actually didn't mention how many times you can repeat, but I follow the minimum functional group. And then at the bottom, perform database search after generation. So tick this, perform database search after generation. Can follow this. I try to go very slow for the first problem. Once you done this, my advice is you go to the save button, you click save, and then you save wherever you like in your document. Here I have my few documents I already saved. So you can name as, I already have the molecule design. Case, I name as case study 1. So save first. Because if you have a problem later on, you can go to this open file. You can select your case and then you can reopen. So that all the parameters or the information that you already declare here won't be missing. Otherwise, if you have problem when you run, sometimes it is closed, suddenly closed, and then your information, everything will be lost. So that's a precaution. Save first. Why you don't have the PDF? I guess I gave to the lecturers to share with all students. Hopefully can share in the groups. I gave to lecturers in the WhatsApp group, and to my student session 1 I put in the WhatsApp group as well in the e-learning. Hopefully you can get that. Is there any message you just voice up? Okay, because I couldn't see the comment. All right, done for this one. But you can slowly follow this one. So now we move to the non-temperature dependent specification. This one you done this one. Now move to this non-temperature dependent specification. So specify non-temperature dependent properties. Right-click, list of properties will be appeared. Tick the selected properties. So now we want to choose the normal boiling point from 345 until 355. So click on the property and then uncheck goal. Okay, how to do it? go for the non-temperature dependent properties, put your cursor in this empty, right click, and then you will see all the non-temperature dependent properties. In our case, we want to have the normal boiling point. Check. Tick the normal boiling point. Again, I repeat, right click, go select on the properties that you want to choose. In your case, in our case, it's normal boiling point. All right, so in order to, you have the minimum, maximum goal. Sometimes we want to design in a range, normal boiling point, in our case, in range. So we need to have minimum and maximum. Sometimes we want to design at exact value. So we just need goal, which is exact value. Sometimes we want to have the greater than or less than. So either one. What you have to do, you go put the cursor to the properties, click, and then it will appear min, max, and goal. So you just tick to disable. Okay, you tick to disable. So since our properties, we need to have minimum, maximum, so we just untick goal. So now you can see the goal is actually disabled. You can key in the value for the minimum, 345, and then maximum 355. All right. Right click, select the properties, go to the properties, and then this one is just click, not right click, just click, and then you will see minimum, maximum, and goal. After you done this, that means that's the only properties that you have to set. For the temperature dependent properties, actually in your case, you don't have that, but you can right click here and then you can see what are the temperature dependent properties available. Density, viscosity. For the miscibility, for the mixture, I will go on the last case study. Hopefully I have ample time to do that. All right, so basically once you finish this one, all right, so you can again save, click button save before you click the go button or run button, which is the green button here. All right, so you ready? You can click the go button. All right, so basically if this box appear, basically you simulation done. So you can see the summary of simulation here. Number of compound design within 0.9 second, it can design up to 54 compounds, 54 structure. But the number of compounds selected is only 17. Number of isomer design 21, and this is your number of isomers selected, only 3. Only 3. That's your results shows 3. If you have this result 0, when you close, and then there is nothing appear in the white ground here. So hopefully you have the same generation like me. 3 and then time is 0.09 second. Why from 54 is just reduced to 3? So here you can see the functional group screening, 21 remove out of 54. This one is screen out, remove. From 54, 21 is not satisfy the functional group. 16 doesn't satisfy the normal boiling point. And then this one is screened out for secondary calculation. Actually, 18 has been removed. So 18 minus 21 is actually only left 3 compounds. So that's why you have this one is summary, 3 compounds only. So you close. Now your white on the right hand side here shows you the compound 1. And then at the bottom, you can see there are a few tabs. So you can navigate your compound using this arrow, right and left arrow, compound 1, compound 2, compound 3. I'm sorry, I couldn't adjust the structure here. You can see the compound 1 is actually, basically you couldn't see the structure, but I couldn't adjust that. It's actually automatically by this program. All right, so what you can see here, you have compound 1 until 3. That's given to you. You can toggle here. And then if you see the description, the groups here, you can notice that, oh, because you decide only one functional group, it must have in every compound. So you can see this is functional group OH. It must have at least one CHO. And then, so this one here is actually not non-functional group. Maximum. Except for this one, there is no functional group. Others it has. And you can see the property values here is predicted, the properties value. And this result, you can do the sorting, click sort, and you can either sort according decreasing or increasing order of boiling point. Since this one you only have one properties, you can sort by boiling point, decreasing or increasing order. I like to have increasing order. All right, so this is increasing order. So this is the properties. And then info, which is basically go back to your result. If you miss your result before, you want to check your result, you go for the info. And property and data bank, I come later. All right, this one here shows that sometimes when you design the compounds, it's a new compound. There's no data bank. So you can click either in data bank or not in data bank. So, and all right, if you, okay, it's now my program is not responding. So sometimes that's why I said that this one is sometimes it's happen. If this happen, that means you have to close and then reopen. So that's why when you save, it's really important for you. Because I click not in database, but actually there is no compounds in not in database. So I have open case study. So this is my case study before. So I'm back. All right. So you see your compounds here is not, there's no name here. You don't know what is this compound basically. So what you need to do is actually you go for the any compounds, click data bank, and then here is actually the compounds that the following compounds from data bank match the first order. All right. Sometimes you will see there are different name appear here because it's just compare the first order group with the database. So these look like isopropanol. So you can go to details and then you can see this is the propanol. It has C3H8O. And then you can go to page 2, you can see the properties, and then you can see the group description. So that's why it's mentioned that it's matched with this group. So that's why it's select as isopropanol. But sometimes you will see a different molecule. So this one is just to find what is the name of that particular molecule. Actually, I want to show you if also you can use ProPred. I try to click my ProPred. All right, so that's the problem with my version. Since this morning, I couldn't open a link between ProPred, but maybe when you click the ProPred, it will appear another screen for the ProPred showing the molecules and with the properties. That's another way. I'm quite frustrated. I couldn't show you ProPred because I want to show you another function that I want to highlight. There is a function on the ProPred. Maybe after this, I will get help from the Dr. Asmadi to show you because I really want to show this function. All right, so this one, the last things that I need you to do is actually you go to the bottom, you see the short, the bottom on the right hand side, short, you click short. Actually, a short will give you a summary, short summary. So I save in my PC the folder. So case study 1, I just name as case study 1 and then save. So I go to the folder. I open the case study 1 By the way, again, I repeat, you go to and then save your file as text file, and then go to your folder and then open the case study one. All right. Here is actually very important summary of results, because you can see the summary. You can see here is the most important part, the result bottom here. If you have many compounds, you can actually copy the smiles here. So let me just adjust this accordingly. So you can see that normal boiling point, and then this is the groups that involve. All right, so this one is on the second order. All right, this is the view of your results. If you have 100 compounds, and then it will list all the compounds here. So this will give you the results here. All right, actually finish on the demo one. Any questions before I go for the second one with more properties?
Doctor, from the results that we got 3 compounds, right? But one of
Yes.
the compounds, it doesn't have the functional group.
Let me check back the maximum number. Oh, okay. Because I set as 0 here. Minimum number of same functional group. Minimum number. Okay, 0 here. Minimum number of functional group. I give as can be 0. That means there is no functional group. Also fine. Minimum number of functional group. If I set as 1, and then it must have at least 1. I think I have in the next exercise, I set as minimum number. We will see in the next exercise.
All right, thank you, Doctor.
Okay. Any other question? Hopefully we can move faster after this. So go to the case study 2, phenol removal. Since you already know how to do it, so you just go, you click a new white button on the left top, on the top left hand side. So click new. So basically a new generate, and then name as phenol removal study, and then the same thing you do. So just read the instruction. So basically this one, general problem state control, what you have, you need to design cyclic compound. This one, you click cyclic compounds, generate isomer, and then you need to have the group of alcohol, ketone, aldehyde, ether. And then take isomer, all right? The size should be 2 to 6. 2, 6, and 1 until 2 functional groups, but not repeat the same functional groups. 1 to 6 minimum. Okay, this one I have minimum because I said that with 1 until 2 functional group, that means it must has at least 1. Maximum is 2. Minimum number of same functional group. Maximum number of same functional group is not mentioned here, but I just use the same setting. Minimum, maximum. Minimum 1, maximum 2 functional group. Repeat, can be repeat. For example, alcohol can repeat up to 2. Ether can repeat up to 2, the maximum number. Perform database search. After you do this, go for the save file, save first. Study 2. Before you go for the next non-temperature dependence, all these actually non-temperature dependence. We have boiling point, we have melting point, vapor pressure, and then log P. So right click on the property non-temperature dependent, right click. You can select all the properties first, TB, TM, and enthalpy of vaporization. Last is log P. Once you tick all the properties, click on the properties. For the normal boiling point is greater than, so it must have the minimum For the melting point is less than, which is a maximum enthalpy in a range. So disable goal. Log P is greater than, so the value is minimum. Set the minimum one. So basically this is how your properties look like. So key in the values. Maximum is 34. All right. All units are. Make sure units, when you have the information from search or from your literature, make sure that the unit is the right unit as in this property. Log P 1.5. So once you've done this, save again before you hit the run button. After this, no temperature dependence, click go. So these are your results. See, you have more compounds. Design 228 compounds within 0.18 second. Not even 1 second. All right. So then close. You will have some working. Here you can see the screen working to generate the compounds, and then you can see here at least one functional group. You have this one, and then you can click all to 25 compounds because it's generate 25 compounds. If you don't have the molecules, that most probably you don't tick if you don't have the data bank here, most probably you don't tick the perform database search. This one is important. And if you don't have isomer, most probably you don't tick the generate isomer. So that's the two things that I always double check before I run. So if you don't have the structure, most probably you don't generate isomer. Let's say I disable, I run. You see, my result is didn't show me the structure because I don't tick on the generate isomer. And then the result is just 7 compounds only. Always generate isomers. And then you will see a different compounds. Any question up to here?
There's a question here. More repeat the same functional groups. Maximum number of the same functional group is 0. Is it right?
Is it in the chat box?
Yeah.
I have to open the chat box. Not repeat the same functional group means maximum number. Not repeat the same functional group means the maximum number of same functional group. Yes. Not repeat the same.
If we put
okay, yes, correct.
If we put 0, then it will be like the last time. There will be a compound with no functional group at all.
Not repeat the same functional group.
It will be 1.
That means it can have
1.
maximum number. Yes, 1. This one is 1. Only 1 because we can have up to 2, but we can have 2 functional groups, but the maximum number of functional group is actually 1 because we need to have 1. This one is not 0, it's just 1. Correct. Like this, so 25. So at least 1. Oh yes, correct.
Yeah, for example, OH. So it's only one OH. There's no repeating for OH.
Yes, or correct. So this one CH2, let's check. Okay. At least 1 functional group it must have. This one you can navigate your compounds and then check the generation. At least 1 groups. The same functional group. It can have 2, but you can combine for CH alcohol and ether, for example. But this doesn't create any the group with the same number, right? Yeah, it doesn't have. Just all one functional groups. Maybe other factors. Maybe other factors that constrain the same functional group. What I want to show here is actually some of the compounds. For example, compound 1 here is like this. You might be, when you do the sorting, you might have a different compounds 1 until 25 if you do the sorting. Now I didn't do any sorting yet, so hopefully you have the same compound as mine. So compound number 1 is look like fish. Okay, fish. So you see there is no data in data bank. You cannot actually what is this actually? You cannot see, but you have the proprietary. You can click the proprietary, and then proprietary should tell you there's this component, what's the molecules property. All the property can be predicted using the proprietary. All right, the spirit of using CAMD is you want to generate all the possible compounds, and sometimes you will found novel chemicals. There's actually not in database, even maybe not appear, maybe not exist yet. So this is one example, the compounds that not exist yet. You don't have name. Actually, when I click proprietary, this one I have been tested. When I click proprietary, there is one button for those who can see the proprietary. You can see one button at the top with the yellow hand. This one maybe I need Dr. Asmadi help me to show that later on. The yellow hand is actually when you click, it will get the name of the molecule. At the top here is a yellow hand showing the direction, like James Bond. You know, the yellow hand. When you click that one, it's supposed to give you name. Dr. Azizo missed to explain this part when he explained on the proprietary. So that's I want to tell you that one is actually when you click. Normally, when you click the proprietary, there is no name, no CS number. But when you click the yellow hand, if the chemical that really exists, it will give you the name, and then it will use CAS number. However, if the molecule is actually does not exist, it still remain as no name. So that's maybe your new. You maybe encounter find a new novel chemicals. I'm not sure. But sometimes when you use this CAMD, it's not considered in terms of the chemical orientation. So might be this molecule is actually cannot appear as exist due to chemically hindered properties. It might be unstable, so it cannot appear like this. Maybe some due because this one is really the O is actually really polar. So I'm not sure in terms of chemical. Might be this one is the reason of chemically unstable. However, in CMD you still can consider is component 1, component 2. So let's move. See, there are few of the component is not in the data bank. So proprietary will help you to identify that. This one's supposed to have, I think supposed to have name this one. All right, so finish this one. Any question regarding this one?
Yes, I have.
Doctor, yeah,
Yes.
I have a question too.
All right.
Doctor, so regardless of its existence, can we generate the IUPAC name of the compound?
All right. IUPAC name is like your IUPAC name. You can because this is not exist in the CAS registry, because IUPAC name is actually given to the chemical that exists. So it must be registered under CAS registry system. Therefore, if the new molecules that you find, you can name as maybe Zankin chemicals. No, just joking. You can give a name, new name for this compound that not exist in your work or in your project, because this compound there is no name. You can give name, but of course you don't have the IUPAC name. you maybe name as solvent 1 or novel solvent 1, and then you have all the properties. You have the smiles, you have the properties predicted using PropRed. You can have all those properties.
But all the names that we give is the common name or the
No,
name?
you can just give the not the normal name, or if you know how to do it, naming using IUPAC, you can name it as using IUPAC name. You can do that.
Okay.
If
Okay,
you know
understand.
how to do the naming. But in our case, we don't naming because we're not sure that this chemical exists or not. We just give a fancy name, a novel solvent 1, like something that you create by your own. Any other
Okay,
question?
understand.
Yes, Doctor, I have one question.
Yes, Akil.
For the summary, like we click the info for each compound. So just now I got the different
Numbers.
number of different number with you. So is it normal if I got different?
Okay.
Even though the parameters the same like you.
Yes, sometimes I'm also wonder why sometimes you get a different. It's supposed to you generate the same molecules, but sometimes we encounter that due to the sum of the functioning group screening, and normally when I use the same specification like here, it's supposed to give me the same answer. But no worry, if you generate that according to your specification, just go ahead with that.
Okay, thank you, Doctor.
Doctor,
Yes.
When I click on PropRed to give us the particular name, it says on my computer unable to load the selected structure at this moment.
Maybe that's one is I think problem with the PropRed, not on the because of PropRed not able to generate. Because me myself, I think my computer I couldn't open the PropRed due to a firewall or my virus scanner. It's actually blocked. I cannot open the PropRed. Unfortunately, I couldn't show you guys. But you can try again later on. I have to restart. This one I think I have to restart in order need to try PropRed again. All right. Any other questions? Before I move to the last one, last one is actually very important. All right, I think I have to move. Yes. Open the new one. So the last one, case study. For those who know how to do it, you just continue. This case study number 3 is actually I get this one from ICAS document. Actually, guys, I want to show you here. You can have this one. Dr. Aziza already mentioned about manual. You can go and then check on the manual. The case study number 3 is actually I got from the ProChem manual here. It gives you step by step how to do the code, how to do the specification in the manual. But other than C, CAPAC, ICAS document, you have also examples. In this example, you can go to the PropRed, you can open any examples here to see. You can go for the ProChem. There are a few examples here. You can see how they give the specification during design all these examples. So this one is actually from the manual. I got this case study 3. It's quite lots of things to do. All right, in the PDF file that I share with you, I give 2 methods. All right, so this one is to design solvent to separate acetone and chloroform. So this one, what the type of solvent that's suitable to separate acetone and chloroform, because we know that this is actually azeotrope mixture. We can do this in 2 methods. The first is using database search. This one, Dr. Azizo already showed with you how to do the database search. Let me go to the M database basic search using the name, This one I use the chloroform. Search CAPAC database. Wrong name. THLO. So you have this one. You can view the compounds and then just view. You don't have to do anything. You can. This is the view. Chloroform solvent properties. You can see under page solvent property page, you can see that chloroform is actually form a soluble with acetone, soluble mixture with acetone. However, miscible with ethanol and ethyl ether. So this type of the solvent that's suitable, can be used with the chloroform. Acetone is soluble. So this one, basic search. And then we can go for the advanced search. You can follow on the notes on the advanced search. You can key in the property one. This is the property one. Tick the property one. And property 2, you have 2 properties. I give in this one in the PDF, I give you the picture. So select the TB. You can type T, and then appear because it's according to alphabet. This one you type S, and then you will get the sol. If you scroll down, it's quite far. It's quite many properties, so you need to just type T and S. So this one, property value 1, is the value is 334, and you should tick greater than. And for the property number 2, solpa, you can click this one in between. So the property value is 17 and 21. So you can search, and then you can see this is all the feasible solvent that can be used for that particular properties using. So these all solvent that are potential. So that's actually how you can search for the solvent properties. Okay, so far okay? Can follow? This one all the possible, but maybe we need to go further to tick on the solvent. Chloroform. Did I miss this in the notes? Oh, I missed this one. Soluble. Sorry, miscible. And then search in database. Okay, this is if you want to find a very specific solvent for chloroform that can miscible, you search and then you can have this the suggested solvent that can be used. If you have a different compounds, you can name the compounds here, and then you select what type of the solvent that you want to have, either miscible, soluble. Please go check what is mean by soluble, miscible. I don't have much time to explain to you on the miscible and soluble, the terms that to use. Of course, totally miscible. We want to looking for the totally miscible solvent. So these are the candidates that suitable. So that's one way to check on the solvent that can be used for the, for example, this one to dissolve on the chloroform. But I want to go on the CAMD actually. This one you can refer back to your handout. So now I want to go for the this one. I want to go on the ProChem. This actually quite many things to do. So the first one, name your problem. Study 3. All right, see on the guidelines, design a cyclic compound, generate isomer that has a group C, hydrogen and oxygen. Select all. So alcohol has oxygen, ketone, aldehyde, acid, phenol. So these are the compounds that has O. And the size should be from 4 to 8 groups. Here, 4 to 8 groups with maximum 1 functional group. Maximum number, minimum 0. 1 functional group here, 1. Minimum number, there's no. Maximum number is 1. Okay, see here the specification. Save. Okay, study 3. And go for those who fast in this computer, you can go very quick because we don't have much time. Molecular weight, normal boiling point, tick on the goal, tick on the goal. This one is 70 up to 120, 340 and 420. This one okay. All right, pay attention for this one, mixture property. Tick mixture property. Specify isotropic mixture as a feed mixture, acetone and chloroform. Specify minimum selectivity. Select chloroform as solute. So this one, Unifact VLE calculation. Temperature condition is not given. Condition here, no, just remain. Select key component, edit. So select from database. Type chloroform, add, and another acetone. Acetone, add. Okay, all right, so it appear. Again, to add a component, click edit, select from database. You know the database, how to do it. Just type the name, chloroform, and then chloroform, click the name of the molecules, click add. Click the molecules and then click add. So, okay. All right, and then here, the key components, chloroform is given here is 0. Click on the key component first, and then type numbers here, 0.656. Enter, and then acetone, type the value 344, and then enter. Chloroform as solute. Constraint, the same. Constraint, right click, selectivity, minimum. Second, minimum selectivity. 1.7. Then despite is almost 1 p.m. All right, this is my specification. Can you follow so far? Once done, you can go to the azeotrope or miscibility. Perform azeotrope. So both you select no azeotrope. No azeotrope. That's I don't take the perform miscibility because in the performance miscibility there are few things that we need to specify. I don't have this information. So tick perform azeotrope, just tick both no azeotrope. I think that's finished, and then you save first to be safe, and then it's 0. Perform. Let me check what's the different minimum. This one. Let me check again. I have 6 here. Azeotrope. Hmm. 118. Oh, okay. I changed the condition. 3, 4, 5. Sorry. Change the condition for this one. 3, 4, 5 is actually for the mixture condition. Oh, yeah. I mentioned in the mixture properties the condition as 3, 4, 5 and 1 ATM. So this one is mentioned in the mixture properties. You specify this, and then this one the same azeotrope. Okay, and then click run. So you generate 110 compounds. So give some times for the generation 110 compounds. So you can analyze the results. You can see your compounds here. 110 compounds. All right. We don't have much time, so 1 p.m. already. I have class also at 2. So any final question regarding this one? You can do it?
No question, doctor.
All right. So I think most of you already hungry for lunch hour. So thank you very much. Hopefully you can apply this in any application, not only for the chemical product design, but if you have any questions regarding ProPred, ProChem, you can always ask us, Dr. Azizul or me. You can always text us how to do it. Especially this one you need to do on your project. At least you have to apply the tools, either KMD, ProPred tools. It's a compulsory. All right, thank you very much. For those who don't have the installer,
maybe I can show about the Propet.
Okay, sure.
Yeah, just for a while. Yeah.
Yes, Doctor.
Where's the program, right? Okay, this one. Careful. Tak boleh keluar ke? Okay. So this one is
Dr. Asmadi. Dr. Asmadi, okay. Dr. Asmadi?
Ya.
Ada?
Sorry. Ada. Tak tahu kenapa tiba-tiba pula.
Lagging eh?
Lagging pula.
Like,
Tak tahu berat.
Nak share apa tu? Appropriate
appropriate, ha?
Boleh tak? Tak
Anyone?
keluar lah.
Just final sharing. Sorry, I couldn't open the appropriate. Maybe someone can help to show the appropriate.
Maybe Dr. Madi can pause kejap video.
Okay, aku dah. Ya.
Dia tengah buka.
Okay. Ada.
Okay.
Alright.
No.
Dr. Asmadi.
So I think this one is the data from the Dr. Alafiza. I just imported from her file. So I think it's down here. You can click the PROPET. Is it correct, Dr. Alafiza?
Yes, correct.
Yeah.
Click the PROPET.
So the PROPET. Take some time there. Oh, lambatnya.
Can open or not?
Boleh. Tadi okey. Itulah dia tengah generate dah. Dah.
Generate. Should be.
Tak kenapa. Berat pula.
My computer langsung. I cannot open the appropriate. I don't know. Firewall is actually suppress this appropriate. Other tools I can open.
How about this one? Okay.
I can. No, I cannot see. Okay, Dr. Asmadi. This one, okay. Dr. Asmadi, can you click on the hand next to the flash? Yes. Search database. Basically, so you can see there is a name. Previously, there is actually no name. So when you click the search database, there will be appear, and then properties, they will give you more values in terms of experimental value. It will appear. So that's actually application on this. Normally, it's just no name. You have to double check. Okay, that's I want to highlight on this one. Thank you, Dr. Asmadi.
Okay. Any question from the student? So if no questions, I think it's already 1:10. Sorry for the delay. Thank you, Dr. Azizul, and also Dr. Alafiza with the nice lecture about the ICAS. So